Hello, welcome to my new video on downloading web radio data and play on the W5100S-EVB-Pico 2. In this video, you will learn how to read and write to external SD card, play MP3 audio with volume control on the board with CircuitPython, and know how to obtain audio data from web radio streams. As usual, you can find related links and codes under the video description. In this video, I will first show how to connect the hardwares, then we will move on to talking about the code and logic inside CircuitPython. Before starting this project, remember to watch the shorts video on my channel to set up the board on CircuitPython. Now, let's start the video. In this project, you will need the following hardware modules. You will need 2 button modules, 1 rotary potentiometer module, 1 headphone jack module, and a SD card reader module. The button modules are connected to GP0 and GP3 of the board respectively, while the knob is attached to GP27 of the board as it is an analog input. My headphone jack module only have 1 channel, so I only attached 1 wire to the GP26 of the board, which outputs analog data, and attached the other wire to ground. Lastly, my SD card module is pre-built with the board, so no connection is required to use it. To connect the SD card module to your own W5100S-EVB-Pico 2, you would need to connect the corresponding SPI interface using SPI 1 of the board, as the SPI 0 interface is used by our W5100S chip. Finally, connect your board to the PC with Ethernet cable connected, and we can now start coding the project. Before starting to code, we need to search for links of web radios. I have searched some web radio links on the internet where you can find the corresponding streaming links on the browser. To obtain the streaming link, you will first play the radio, then use the browser's developer tools and go to the Network tab. Find the element where audio is playing, and you should see a request to an URL receiving MPEG data. You can try this method on different web radio website and check whether you can download the data onto the SD card afterwards. For this project, you will need to unzip these libraries to the lib folder of the board from the library zip folder provided by CircuitPython. Now, open the editor on CircuitPython and set up our code in creating a request session with the following code. This completes the basic setup of the board. Next, let's connect the SD card reader on CircuitPython. Following this article, we will need SD card I/O and storage module for the board, which are already initially stored to the board. Since our board's default SPI interface is used for the W5100S chip, we define the specific pins for the SPI 1 connection. Referring to the board's documentation, SPI 1 can be used from GP8 to GP15. In my program, I use GP12 to GP15 for the SPI connection, and the code to mount the SD card to my board is as follows. To test if you have successfully mounted the SD card, you can import the OS library and try the list directory function to show the files in the SD card. Next, let's download the data from the stream links. Set up the file path of the download destination. The variable for data list is to combine the chunks of data together before writing into the file, and the new file variable is to check if we are writing to the file for the first time. Also, set up the button variable. This is used for 2 different purposes. You can either use this to stop the downloading portion in the download part, or start playing the audio when used in the play audio section. Next, initialize a dictionary of available URLs that you can download in chunks. These are the URLs that I have tried that you can use to download data in chunks. Note that other than the first 5 items in the dictionary, the remaining URLs only allow 60 seconds of connection, so before you add new URLs to the dictionary, you are advised to try the URLs first to see how the downloaded file performs. We can now make a request get to the stream link. Since the file is too big to get from the server, we need to set stream to true to download data in chunks. Check for the status code of the server and only continue to the download section if the connection is success. Inside the download section, We use try except keyword since sometimes OS error will occur. To download the files, we first need to use a for loop to loop the content inside the response using iter content function. The integer inside the function represents the number of bytes each iteration will be reading. Next, we extend the data list using chunk until its memory is full. During this process, we will also check if the button is pressed or not to cancel the download. Once the data list reaches its max memory, we will then write the data to the file. If it is the first time that we start writing to the file, we use open function with write byte argument to write to a new file. Change the state of the variable to avoid rewriting a new file every time a new data list reaches its max memory. If it is not a new file, we append the file with the data list using the argument append byte. After completing the writing process, remember to reset the byte array and extend it by the chunk that is not stored due to reaching the max limit of the previous array. Lastly, I added the latency for checking the time to write each data list to the file and for letting me know data are being written to the file. Inside the OS error section, we use the same logic to write the saved data in data list to the file. Do the same to save the data if you decided to quit using the button. Lastly, close the response and decide if you want to quit the program by using sysexit function, or you can comment this section and directly go to playing the saved audio. Next, we can start playing the audio. To play the audio in this project, we will need to use these 3 libraries, which serves different purposes. As my headphone jack module is created based on this circuit which uses PWN output, we use the audioPWNout to play the sounds. However, before playing the audio, we need to use MP3 decoder from audioMP3 library to decode the given MP3 file. Lastly, the audiomixer library is used to adjust the volume of the audio playback. After introducing the purposes of these libraries, we now can create objects that controls the playback of the audio. I created a knob input at GP27 for volume control and a button input on GP3 for pausing or resuming audio. Next, import the libraries and set up the MP3 decoder and audio output as follow. Use 2 variables to track the state of the audio play. These 2 states will help us determine whether to resume or pause the audio. After checking whether the file exists using OS stat function, we can import the audiomixer library and set up the mixer with the following parameters. Note that I used a larger size of buffer to play the audio as the default buffer size causes buzz noises in the audio. Next, attach the file parameter of the MP3 decoder with our MP3 file. Create a while loop to continue playing the audio whenever we press the button at GP0. After pressing the button, we first attach the mixer to the audio output. We also need to attach our MP3 decoder to the first and only voice of the mixer. Use mixer playing to block the main program until the mixer finishes playing. We can add our controls to the audio playback inside this while loop. To change the playback state of the audio, we need to compare the current button value with the previous button value. The only time we need to do any changes to the play state is when the current position is false, which means pressed, while the previous state is true, which means it is not pressed. Change the state variable every time the upon condition is met. If the state value after using the not statement is true, we resume the playback, and we do the opposite if the value is false. Next, we can adjust the volume of the playback by reading the position of our control knob. The upon formula is used to scale the values from the min value to max value of the analog input to 0 to 1 value of the volume level range. From my testing, 800 is usually the lowest value of the knob while 65500 is the max value. You can change these 2 values based on your testing on the knob module. I also raised the normalized value to 0.6 power as human ear does not follow a linear scale in listening to audio. Lastly, since there will still be instances that the min value is less than 800, the final value outputted may be in complex type, and if it is complex type, we simply set the audio as 0, while if it is not complex type, we just set the level according to the value of the formula. Update the previous state for pause resume function and use sleep to save resources between each iteration of the while loop. Use a time sleep function to avoid continuous playback of the sound if you hold the button for too long, as the decoder or mixer needs some time to reset before the next playback. Close the files of the decoder file and MP3 after completing the while loop. Here is a demonstration on how the device should work. I changed the headphone jack module to a speaker so that you could listen to the sound. The connection for the speaker is the same as the headphone jack module, where one end is at board A0 and one end is at ground. This is the end of the video. I hope that by this video you learn how to read and write to an SD card, use getRequest with stream is true to get streaming data, and use audio libraries provided by CircuitPython to play audio on your board. If you like this video, please like, follow, and subscribe to my socials for more updated content. If you are interested with the pre-built board, you can go to this Hackster.io page, which explains the functionalities and development process of the board. Comment down below if you have any questions related to this project. See you soon.